I was saying that for the process creation, fork system call is used, and for the process deletion, as soon as the process executes, a system call is invoked, that is exit. Clear? PC, fork, PT, exit. Clear. Now at this point, the process may return the status value. To which process? To the parent process, right? Now, as we've learned that till the child process complete, the parent process will wait, right? Now, what is the statement is with the statement we should understand that as soon as it done with execution by prompting a system call exit, at this point of time, the process will return its status. To which process? To the parent process, right? Which with which system call? With wait system call, right? Now, as soon as these type of system calls invoke, immediately all the resources, what all the resources are acquired or provided to the concerning process, like it could be a hardware or a physical or a software or a memory or a files or a buffers or IO resources, everything is deallocated by the operating system. Okay, so before the process could start its work, all the resources were allocated. What are those resources? The resources were nothing but memory, IO resources, files, etc. Right? Now, as soon as the child and the parent process complete its work and being terminated, then all these resources will be allocated by the operating system. Right? Now, whenever this termination occurs, a process can cause the termination of another process via appropriate system call. If it is window 32, the system call for terminating the process invoke is terminate process. Okay, this is what the system call named is being defined and declared in Windows 32 operating system. Clear? So such type of system call can be invoked only by the parent of the process that is to be terminated. Please try to understand the things over here. I repeat once again, in case of Windows 32 operating system, an appropriate system call is invoked in order to terminate another process, that is terminate process system call. Right? Now, otherwise, users could kill each other jobs. Users could kill each other jobs. Can someone tell me what is that system call should be invoked to kill the process? You heard this word is familiar to you when we were uh, uh, discussing the topics in database management system in terms of transactions. A
About
transaction can be killed. A bot, right? Very good. So here one point should be noted, that is a parent needs to know the identities of its children. Identities are nothing but their IDs, right? So when one process creates a new process, the identity of the newly created process is passed to the parent. Let's say parent process with ID 1 is created, children process with ID 1. Okay, this ID should pass to the parent process. Does this ID is assigned by the parent process? No, IDs are assigned by OS. Clear? So with which ID the children or a grandchildren from this process is created, that information has to pass. What happens if concerned information is not passed to the parent process? Then, as we've seen that till the child completes parent wait. Right now, how does this parent come to know that whether my children is terminated, whether my children is stuck anywhere with any interruptions or not, or to which for which process I should wait, which process is my children or a grandchildren? In order to avoid such confusions, how many of our children or our grandchildren are created under a single or a parent process? All their children or grandchildren IDs must and should pass to the parent process. Clear? Now, a parent may terminate the execution of one of its children with variety of reasons. The reasons are listed over here. What are they? The child has exceeded its usage for some of the resources which were allocated, and in order to determine whether this has occurred, then the parent must have a mechanism in order to inspect what is the state of its children. If it is exceeded, that should known to the parent, right? So every time the parent process should inspect the children and the grandchildren's. So whatever the resources I have allocated, is it exceeded or not? Right? Now what happens? If the resources are exceeded, then the parent can terminate the children. Right? So not only that, the child process, it may also affect the other child process where the other child process could not acquire the resources which they are looking for. Only if the child has exceeded with allocated resources. The next reason, when a parent can terminate the execution of the children processes. The next reason is if the task assigned to the child is no longer required. See, it can be seen in two cases. See, a child process is assigned with some task. Maybe sometimes the child process could have completed its work, or the child process is not doing anything. If any process is doing nothing, then the parent process will simply terminate the child process. Okay, if an assigned task to child is no longer required. एक time था, that child process task is very much useful or necessary to go under execution, which acts as an input to the another process. Right, it's done its work. Now as soon as it's done its work, then what happens? Simply parent process delete the child process. Why? If that parent process can delete the child process which is doing nothing, then what all the resources were acquired by child process, everything gets free, isn't it? Now this amount of memory, IO resources, if file systems, if those resources needed by another children, then they can acquire it. Okay, in this fashion the process get create and acquire the necessary resources by terminating the child processes if and only if the task is completed, then only. Clear? Another reason for terminating the child process is the parent is existing and the operating system OS does not allow a child to continue if its parent terminates. I repeat, another reason for terminating the child process is the parent is existing, right? Sorry, exiting. Exiting means what? This system call is invoked. It means the time comes when the parent terminate. And what happens? This OS does not allow a child to continue when the parent is terminating. I repeat, how many of you remember this operation? Cascade on delete. We have this point in the next slide. Okay, at that point I'll ask you. So I hope you understood, right? Now what are the basic reasons for terminating the children? 3 reasons we discussed. About the third reason, we will discuss more. And some systems like virtual machines, it does not allow a child to exist if its parent has terminated. isn't it? Now, if a process terminates, it can be normally or abnormally. Then all their corresponding children, can be a children or a grandchildren, also should terminate. If parent process terminates, then all their child process should terminate. This is necessary and mandatory. Okay, this process is known as cascading termination. Now at least you could remember or recollect the process of cascading command. Yes or no? No? What is meant by cascading on delete?
Parent
In
is
DBMS
delete.
we have learned on delete,
No action.
cascade, on delete, no action. Isn't it? These were the two constraints we've learned. Someone is saying, tell me dear, the what is mean by on delete cascade?
If parent is deleted, then corresponding child is also deleted.
Very good. I hope everybody understood this, right? As soon as the termination is initiated by the operating system with exit or window or termination process system call, then corresponding children also get delayed, irrespective of whether the children tasks are completed or not. Because in the initial state itself, the process can be terminated either normally or abnormally. Okay, if it is normally, might be all the children process have it completed with their task. If it is abnormally, then there might be some misuse or disruptions from the parent side as well as the children or grandchildren side. Okay, now in order to illustrate the process execution and termination, we can consider one of the system call from Linux or Unix operating system, that as a process is terminated by exit system call, its parent process may wait for the termination of child process by using which system call? Wait system call, isn't it? This wait system call is invoked to which process? Your options: children process or a parent process. Which process? Children or a parent? Parent process, isn't it? Now, as soon as the wait system call returns, as I said that everything has to be returned, right? In terms of what? ID, right? So it is returning to the parent process along with its status, right? Now, the wait system call returns the process identifier, that means PID, of a terminated child, so that the parent can tell which of its children has terminated. As I said before, every parent process should have known information of which process is getting to terminate, or which process is in executable mode, which process is in waiting mode. Every ID of grandchildren or the children has to be returned to the parent process. Okay, depending upon their corresponding operations, then the OS invoke a wait system call to a parent saying that your child is in executable mode. You have to wait until unless the child process get terminate. Okay, so moving forward, this wait system call can be viewed in two different ways of, two different representations of process. One is zombie process and the other one is orphan process. So these relating to children and a parent process when the time comes to terminate it. Okay, zombie process is nothing but if no parent is waiting, if no parent is waiting, if no parent is waiting means what? It might have not invoked a wait system call. No wait system call. If no parent is waiting, Such type of process is known as zombie process. Okay, now another type process is if a parent terminated without invoking wait. Without invoking wait. Now, can I consider uh, uh, a child process without a parent? Isn't it? If parent terminated without invoking this system call, such process is known as orphan process. Orphan process. Now, in detail, I would like to give you a few definitions of the zombie process and the orphan process in detail. So basically, this you would be learning in detail in Linux programming subject. But I would just give you the definitions. Those who want to write, they can write. A zombie process is also known as defunct process, DEFUNCT. It is a process that has completed execution via which system call. Whenever execution term exists, it means word system call invoked, that is exit. But that process still has an entry in the process table. In Linux programming subject, we would be rendering it as process table. Okay, but for our understanding purpose, this concept were introduced with which concept? PCB, right? Process control block. But still it has an entry in that table. It is a process in the terminated state. And this occurs for child processes where the process table entry is still needed to allow the parent process to read its child exit status. Right? So once the exit status is read, so what does it mean? Should I mean that the child process is terminated? Yes. When the system called exit is invoked for which process? Child process. Then that status is read by a parent via another system call which is invoked by OS, that is wait. Okay, so this would be done by the parent process. In short, I would like to tell you.
Ma'am, sorry, ma'am. Can you explain this again? Ma'am, I got confused.
Which one?
Zombie only, ma'am.
Zombie?
Both, ma'am. Actually, orphan and zombie process both.
Yeah. So now till this point you understood, right?
Yes, ma'am.
Huh. I repeat, zombie process is also known as defunct process, right? So here two types of system calls invoke, right? A zombie process, you call a process as a zombie only if a tree hierarchy exists. It means a parent process has their children processes, right? इसको हम zombie process बोलते हैं, right? Now a zombie process is a process which has completed its execution. It means with an execution, it doesn't mean that it is completely deallocated from the memory. No, even after completion of the work or the task which is assigned to, but still it has an entry in the process table, knowing which child process is in which state. Okay, now currently the process which is in completely executed, that process could be rendered as terminated state. It means the status of that process. Clear? Now, whenever this takes place, this occurs only for which processes? Child processes. Okay, so it means what? A child process, there's a turn come to the child process which go under execution. Right? So this occur for the child process where the process table has entry to allow the parent process to read the child exit status. Okay, in short, I'll tell you once again. This is the functioning of, this is an operation among the parent and the child process. Okay, so whenever a parent comes to know the status of the child, whether the child is in waiting state or exit state. So when the time comes, the process is executed with invocation of exit system call. That status is passed to the parent process. Passed means the parent process has read the status of the child process. Now what is the current status of a child process? What is the current status of the child process?
Some
This
terminated state.
very good, terminated state, right? Child तो execute हो चुका, कैसा पता चला the child is executed? When parent has read the child status as exit. Okay, now this exit status is read by the parent. Immediately another system call invoke to the parent or alerting the parent that child is completed by invocation of another system call, that is wait. Okay, parent not has a children called parent 1. This children has completed, right, by invocation of exit system call. ये तो हो गया, ये हो गया बोल के parent process को कैसा पता चलता? This parent should read, right? This parent should know the status of the child process, right? Because to make the entry in the system table that these children processes are completed, so that this parent will not spend waiting on the completed process and move to the another process which is in execution mode. Clear? Now यहाँ तक तो clear है ना? This child process has completed. That is why it is rendered as terminated state. But only the child process has completed, and parent is making an entry in the table saying that only after reading the state of a or the status of the children process, saying that this child process has terminated, right? Now how does this parent come to know that the child process is exited or executed? Immediately whenever executed or exit system call invoke, immediately the fraction of milliseconds another system call invoke to the parent saying that your child is executed, now you have to wait. Okay, it means now your child has executed मतलब क्या है? To in the fraction of milliseconds, two things takes place. When this system call executes, here we should understand that child process is in termination mode. Okay, as it is executing each process within a fraction of milliseconds, the same instance of time the children process might have completed, right? Wait time पे ये system call invoke होगा. What is that? Wait, right? Only after the child process is successfully terminated, then the parent process gets terminated. It ensures whether all my children are successfully terminated or not by reading their status. Okay, exit ka matlab you have to understand, remember that the process is completed. Okay, so by knowing the status or reading the status of the children process, it updates the process table saying these children have completed. Is that clear?
Yes, ma'am.
Now let us move on to the next type, that is orphan process. An orphan process is a process that is still executing but whose parent has died. Okay, so when the parent dies, the orphan child process is adopted by some system call, that is init or system D with corresponding process ID. It is not very clear that is there any other process is adopting this child process which is with no parents, I mean no parent process. That is not clear in this definition. If you want, I'll find out more and more in the programmatic way and examples to differentiate zombie process and the orphan process. Okay, in short, understand this orphan process is without a parent. Initially the parent process might have created, but abnormally the parent has died, or died इसको हम ऐसा बोल सकते हैं, like kill or abort. It means it is
Ma'am,
not
then
terminated.
doesn't this violate the rules of process termination, basic rules of process termination?
Pardon?
Like, doesn't this violate the basic rules of process termination then?
Yes, it violates. It violates. So that is why this takes place. So that is why I told you, no, before the process can be terminated normally or abnormally. So can I consider this kind of case under abnormally? See, is there any meaning if parent has died, but still the child process is in executing? To which process it is returning? Under which process it is computing the task? Isn't it? This child process may be adopted for another process. See, two parent processes are there, right? This processes has a child, right? So we can understand this with this illustration, right? This parent has abruptly aborted or killed because of some abnormality, right? So, or some ambiguity. Now what happens? Parent processes died, but child processes executing, because some of the resources have already assigned by the parent to the children processes, right? Now such type of child process might be adopted by, here it is saying that these system calls by knowing their IDs, right? But there is no meaning that child process running their task without a parent. Now, instead of see demolishing this or destroying this children process, what if another process comes into a picture? If it is needed, then better it would save, I mean, adopt these two children. If this work, this task, this children task is corresponding to another process, isn't it? That may be the situation. Anyhow, I'll find out in detail about the zombie and the orphan process. As this is not exactly there in your syllabi, just gives you like overview of this type of process do exist in terms of parent and a children or a grandchildren process. Okay, so for you, I'll try find out, figure it out. Okay. Now the multi-process architecture is the general topic for you to understand the multi-processes in terms of different types of processes. As you can see, how many tabs are open in a browser, right? And whenever these many tabs are open, how a process manage their interfaces, some resources, right? And how a process deals with the web pages, the code and all, and how this gets created for individual website as when it opened, and plugins for individual process types. Okay. Next, coming to the interprocess communication. Still 9 more minutes. Okay. Generally, the process. We are headed to the next topic, important topic, interprocess communication. Generally, the process executes concurrently in the OS, either by independent processes, cooperating processes. A process is independent if it cannot affect or affected by the other process. Independent. In case of independent, it is stated as a process is independent if it cannot affect or be affected by other processes executing in the system. It means all the processes are independent in nature. It don't disturb the other process. If that process is affected, only that will destroy. And any process that does not share data with any other process is also known as independent process. Okay, it doesn't share, it doesn't take anything from other processes. So it simply deals with the assigned task. If it is done, it's simply terminated. Otherwise, it terminated abnormally. Now, another type as the process executes is cooperatively. A process is cooperating if it can affect or be affected by other processes executing in the system. Cooperating means what? Multiple processes are executing cooperatively by sharing the data or the resources, right? So if these two processes are sharing some data, now if any abnormality takes place with one process, the first process, which has been sharing the data with another process, if it is affected, then the corresponding cooperative process which is being shared also get affect. Okay, simple words, if one process affect, the other process is also affected. Now, there are several reasons for providing an environment that allows process cooperation. Firstly, information sharing. Since several users may be interested in the same piece of information, like sharing the files or some resources, we must provide an environment to allow concurrent access to such information. Okay, here it is giving a reason that in which case, what are the reasons where the process run cooperatively. The first reason is sharing an information. The next reason is computation speed up. Like if you want some assigned task to execute very fast, then what can be done is simply making or dividing the complex task into as many as subtasks, right? So such speed up can be achieved only if the computer has multiple processing elements. Like what? Many CPUs, right? Each CPU would be busy with one subtask, right? Now, the third reason is modularity. Now, what is that reason for processes executing cooperatively is dividing the system functions into separate processes. I repeat, dividing system functions into separate processes. You can also call them as threads. About these threads, thread scheduling, and we've already learned about the process scheduling, right? The thread scheduling we will see in the next chapter. Now coming to the third reason for cooperating processes, convenience. An individual user may work on many tasks at the same instance of time. Like see, for example, you open the Word document, what do? You edit that, right? And as you're done with editing part, you give a call for print command, then you switch to another window, you compile the program, right? You switch to another window like WhatsApp, you do chat, right? So everything should be done in a convenient manner. It means what? A user is dealing with multiple tasks at same instance of time. Clear? Now what does interprocess communication